This video is going to talk about opposite values. So let's go ahead. Yeah, we're done with that. We're going to use integers to show gains and losses, to show if we get something or if we lose something. Integers are a convenient way for describing things that are the opposite in the same way. For example, if you play a game and you gain $3 in one move, you would use the number 3 to represent how much your money changed by. If you lose $3, you would also still use the number 3. So in order to show that, one of these would be positive and the other would be negative. Because it's the same amount, that would end up canceling each other out. If you get $3 and then lose $3 in like the next 6 seconds, you end up really not having any big change in the amount of money that you have. They want us to write the integer that describes the action. So if you gain $4, that's you adding $4 to your wallet. If there's a loss of $6, that's $6 being subtracted out of your wallet. A loss of $5 minus 5, a gain of $2 plus 2. Which day was better here? Obviously, a gain of $3 is better for your wallet than a loss of $4. Even though the 4 is bigger, you're losing that amount rather than getting it. So go ahead, look through here and figure out which one of these was a better day. In letter A, you gained money here, you lost money here. Go ahead and take a look at the rest and then we'll talk about it. Welcome back. In letter B, if you lose $2, that's sad. Losing $1 is also sad, but I'd rather lose $1 than lose $2. In letter C, if I gain $3 or I gain $4, which one's better for my wallet? Gaining $4. In letter D, 5 and 4, 5 is bigger, but if I lose $5, that's not good. I would much rather gain $4. Integers can also be on the number line. They want us to label these on the number line. So if this is 0, all of these on this side are positive. Everything on that side is negative. So if I gain $5, that's going to go right here. Losing $2 would go here because it's negative 2. Gaining $1, losing $3. The cards are in order from least to greatest, but we want them in order from worst result to best result. So you can see here that we have, we want to know about the worst from the best. Well, losing $3, that would be the worst. Gaining $5, that would be the best. So let's take a look at which one's better. Gaining 3, losing 5. Always better to get 3, to get something than to lose anything. Gaining 2, gaining 5. Well, if I'm getting something on both of these, I want to get as much as I can. That's going to be gaining 5. Losing 3, losing 5. Oof. Losing 5 is a lot. Losing 3, not as much. Losing 6, losing 2. Losing 6 is a lot. Losing 2 is not as much as losing 6. Think about protons and electrons. Protons have a positive charge. Electrons have a negative charge. So if I want to know what is the electrical charge here, 3 protons would be 3 charges in the positive direction. 2 electrons would be a charge of negative 2. 4 protons would be a charge of +4, and 5 electrons would be a charge of -5. We could also figure something out like 1,700 electrons, which would be -1,700. Look at this. Now we have pictures. Proton, positive. Electron, negative. What's the charge in letter A? Well, I see 2 positives, so that's +2. Letter B, there are 3 negatives, so that's -3. Letter C, there are 6 positives, so the charge is +6. Letter D, 4 negatives, so the charge is -4. Now, the interesting thing about this is that electrons and protons actually cancel each other out. So, protons, if they're in the same area, they cancel each other out. We had an object that has a charge of +2, but then we get a negative, so the object starts off with 2 positives. If we add a negative into there, these remove each other, and now the charge is just +1, because the negative and the positive make each other obsolete. So what's the electrical charge in these? Well, the first thing we need to do is we need to cancel things out. I see a positive and a negative here. They're going to cancel each other out. So this charge is just -1. I see a positive and a negative here. They're going to cancel each other out. So this charge is just -4. Over here, these each have a pair to them, which means this charge, there's nothing left, just 0. When there are more electrons than protons, the charge is negative. Protons and electrons have opposite charges that cancel out, which is why we use integers to represent them. I hope that you have an absolutely fantastic day.